One, it asks us to calculate the mass percentage of carbon in this equation. So to find that, I found the molar mass of each like element in equation, and to do that, I just used the molar mass of each element times how many of that was, times how many of the element there were, and then I to calculate the carbon percentage, I said here's how much carbon there is, and then divided by, I added up like the entirety of this molecule and divided it to get this number. Then I multiplied it by 100 to get to find the percentage value. So I found carbon makes up 15.9% of the mass. For number 2, it asks when heated to 220 degrees, this compound dehydrates completely as represented below. It gives the full equation for that, and it asks you to find how much of this substance on this side of the equation would be formed if you started with 3.221 grams of this. So to find that, I first found the molar masses of each part, right? So I found the molar mass of this, here, and here. And then to calculate it, I said, to find how much of this is created, I said, so 3.21 grams of this times 1 mole over 151.03, which is that thing's molar mass, times 1 over 1, because one of this creates one of this. And then, so I found that creates 0.02125 moles of this substance here on this other side of the equation. And then to find the gram amount for that, I took that amount and I multiplied it by the molar mass of this here. So there's the molar mass. And then and that gave me the gram amount. And then for water, I said I kind of did the same thing over here, except for instead of it being 1:1, it was 3:1 here, because one of these creates 3 of these. So I said 3:1, which gives you basically 3 times the moles of H2O. And then I did the same thing. So I did that times 18, because that's the molar mass of water, to find 1.15 grams of H2O. And then, yeah, so for the answer number 2 is 2.06 grams of this. And now question 3 asks to calculate the volume of water vapor released, and then it gives you the different conditions, the other parts of the equation you need to know. So the equation you use is PV equals nRT, and then so I kind of filled out all the stuff we knew, right? So we know the pressure is 1.05 atmospheres. We don't know the volume, because that's what we're trying to find. We know this, so N we know is 0.6376 moles of H2O, and we found that over here, right? So we know there's 0.6376 moles of H2O being created in this equation. And then here, this is the ideal gas constant, which is always the same for every equation, so that's right there. And then temperature is given in Celsius, but I added, but to convert the Celsius to Kelvin, you have to add 273.15, which is the same. So for all numbers, for all like Celsius to Kelvin conversions, you just add 273.15. So I found that, so we know this. So then I plugged all those numbers we know into this equation. Then I multiplied these out to get here, and then I divided both sides by 1.05 to isolate volume, and I found volume to be 2.46. So that's how I did these equations, and